pleasure to be able to tell you just a brief overview of a project that's ongoing in my lab. I'm a microbiologist, and I am fascinated by all things microbial. This includes the good microbes that we know of, for example, that help us make cheese and yogurts, but also the nasty ones that can cause very serious infections. And I'm going to focus on the nasty ones today and in relation to hospital-acquired infections. So hospital-acquired infections are a huge problem. Patients are very vulnerable when they come into the hospital, and acquiring an infection within the hospital can complicate patient care. It costs billions of dollars annually, and most important, it can have a devastating effect on patient health. Now, I think we're starting to appreciate that there are factors that can lead to an increase in the severity of infections that perhaps weren't always appreciated. And one of these factors is actually exposure to anesthesia. So it's becoming well recognized that anesthetics themselves can increase the risk of severe infection. And in my lab, what we've done is we've chosen to focus on one of these, well-characterized anesthetic agents, which is propofol. So propofol is very widely used in inpatient and outpatient settings, and it's really lauded for its rapid onset and offset of sedative effects. Unfortunately, what we found with this critical anesthetic agent is that it can increase the severity of infection when we look at animal models of infection. So we use a mouse model of lung respiratory bacterial infection, and we can compare then the mice that have been briefly sedated with propofol for 5 minutes and compare them with other sedation methods. And what we've seen, and what I'm showing you here, are lungs taken from some of these mice. The mice that were exposed to propofol have these large areas of abscesses that form within the lung. It's the dark purple that you can see hopefully behind me on the screen. We don't see these same large abscesses in animals that were sedated with alternative methods, such as ketamine. And what we can do is if we zero in on these abscesses, we can see that they're packed with bacteria. And that's what I'm showing you here, shown in red. That's an abscess that's just filled with replicating bacteria. Now, propofol is broken down by enzymes within our bodies, and we have noticed that if we block one of the common pathways for propofol metabolism, and that's what I'm showing you behind me here on the screen, we can actually end up with a form of propofol that still acts as a sedative, but no longer exacerbates infection. And that's what I'm going to show you here on the right side of the screen for you. This is animals, again, sedated 5 minutes with propofol, looking at bacteria in the blood, which is the blue graph. We see large numbers of bacteria within the bloodstream, but if we use this modified form of the drug, we still get sedation, but you can see that the bacterial numbers are way lower, on the order of 100,000-fold. So what we're hopeful is that perhaps this will allow for the development of modified versions of this very important anesthetic with an increased safety for sedation and avoiding some of the nasty effects from those bad bacteria. Thank you very much.